running the Speeduino on the bench with the aid of a stimulator, which simulates the electrical systems on an engine. If you soldered your own Speeduino kit, it's a good idea to run it on the bench first to test that everything is working properly before you install it in the car. Or if you're totally new to automotive electronic systems, you will learn a lot about how they work by running it on a bench. The first thing we'll look at is the trigger section, because this is the most important signal on the Speeduino. I'm not an electrical expert, so I can only give you a very simplified version of what's going on. The Speeduino only accepts a 5-volt square wave. Why square wave? Because digital only accepts fully off or fully on signals. And why 5 volts? Because the Mega uses a 5-volt digital signal and can only understand 0 volts and 5 volts. So we have to make sure all our triggers only put out 5-volt square waves. There are many ways to simulate this 5-volt square wave, but the most popular is with the Ardu-Stim program run on an Uno. And to find the instructions, we'll go to the beginner's guide in the forum. So we go to the index page, select General, select the beginner's guide by a beginner for before you begin, scroll down to testing, and trigger stimulator. Open the instructions. Alright, download Ardu-Stim from here and look for the download. Pick which one you want. Back to the instructions. Download Serial UI and install Serial UI library into Arduino IDE. Direct download here. We come down to here and there's the instructions on how we add Serial UI to Arduino IDE. So you won't actually be downloading a file to add to it. So we open Arduino IDE. Sketch, include library, manage libraries. Type in Serial UI here. Version 2.2 is the latest and I already have this installed, but if you don't, this will be highlighted and just press install. We close that. Back to the instructions. Load Ardu-Stim into the Arduino IDE. So we look for the Ardu-Stim file we downloaded here. We extract. In Ardu-Stim master we open that up, and Ardu-Stim, and we have to load this one, Ardu-Stim INO. So it's file, open, go through your file structure until you get to Ardu-Stim INO, open. We open Device Manager. We open our comms. We plug an Uno in. We have COM29. Back to our Arduino IDE. Tools. Board. Genuine Uno. That's correct. Come to our port. We have port 29. Correct. And now we just compile and upload. Done uploading. We don't need the Arduino IDE anymore, so we close that down. Back to the instructions. And we download Druid for Arduino. Direct download here. We scroll down. And we grab our download. I'll take the Windows executable. 1.31 is the version I'm using, so the Windows one is the exe. We'll save that. Go to your download and run the executable. Could not create a new connection package. Go to port settings. Put in our 29 again. If it's not there, you physically type it in. And now we are connected. And now we have to physically wire the Uno with Ardu-Stim to the Speeduino. So it's back to the instructions. And scroll down to this diagram and wire it up like this. Pin 8 of the Uno outputs the crank pulses, so you'll connect that to VR1 positive on the Speeduino. Pin 9 outputs the cam pulses, and that goes to VR2 positive of the Speeduino. Then you just need to connect the grounds of the two together, so these 5-volt pulses have a path to return back to the Uno. For the pin diagram, just go back to the Wiki main page, go to which board you have, scroll down. Here is your VR1 positive crank input, and here is your VR2 cam input, and just pick any of the grounds on here. Back to our Druid for Arduino. If you've unplugged and replugged the Uno, you'll have to reinitialize. So go File, Reinitialize. It's connected. First thing we'll go for wheel options. Then pick list of wheels. We'll pick something very simple. Wheel 1 is 4-cylinder dizzy. Here. So we choose the wheel. We'll put 1 in. OK. Check that it's the right wheel. 4-cylinder dizzy confirmation. Back to the top. We can set a fixed RPM here. It's currently on 6,000 RPM, but we'll select something else. 4,000. OK. Confirmed. Now we open Tuner Studio. Open our last project from the last video. Now we notice the RPM is not working, so we have to configure this to accept that trigger pattern. Settings, engine constraints. This is a 4-cylinder which matches our 4-cylinder dizzy. We close that. So we'll go Settings, Trigger Setup. We'll select our basic distributor. Burn that. Close. Spark. Spark settings. We'll do waste. Burn. Close. Restart the Speeduino. (4,000 RPM), like we set. Now we'll set a sweep RPM. It has to be in this format: minimum, max, and RPM rate. So I'll go 1,000, comma 6,000, 1,000 RPM per second. OK that. Confirmed. 6,000 to 1,000. Because of the camera frame rate, the LED is looking consistent, but you can kind of see it slow down. And that covers the Ardu-Stim tutorial. On a side note, you don't actually need a Speeduino to do this. You can connect directly to a Mega without the Speeduino. Just look up the schematic for the board you're using. Go to crank and cam sensors. Here's VR1 positive in. This is our jumper, Hall and optical on this side and VR on this side, because this side goes to the VR connector. Follows down here. TAC1 CPU D918, click on that. Notice everything turns yellow, and if you look over here it'll turn yellow too. So it's connected to that. Then you have to chase this pin down, which is D19, and that's where you connect it to. Cam is the same, D18. And of course you also have to connect your ground. Notice it goes yellow. If it doesn't trigger properly, you go to your Wiki for your board. And if we look at jumper configs, there's JP4 and 5, which are pull-up resistors to stop any ground float that might be mistriggering it. So you might have to add them to your Mega. I'll put a link to a video showing the Mega and Ardu-Stim running on their own. There are other ways to trigger the Speeduino. Like I found for this 555 square wave generator, and I liked it so much I found the schematic and actually incorporated it into my simulator stimulator design. On a side note, the JYE Tech DSO-138 has been invaluable in tracing signals. It's cheap, small and portable, and ideal for the low frequencies we are dealing with here, so I highly recommend it. Try to buy a genuine, not a fake copy, as this supports the designer. There is also an updated version, the DSO-150 shell. You can even run it mechanically with a wheel on a motor. Some optical sensors, and even magnets embedded in a wheel with a hall sensor. You can even build a mechanical rig with the crank and the half-speed cam and cheap Arduino sensors. You can even build rigs that will test the actual wheels and the sensors you'll be using.